Hello, everyone. Thank you for joining me today, taking some time out of your day. Let's talk a little about cake and a lot about automation. Before we get started, my name is Paul Grizzaffi. I'm a principal automation architect at Cognizant Softvision. I spent my career focused on automation, and I'm an advisor to two different organizations, STPCon, the software test professionals that put on STPCon twice a year, although it's been a little hard with the pandemic to do live conferences. And I'm also an industry advisor for the Advanced Research Center for Software Testing and QA at the University of Texas at Dallas. If you would like to get in touch with me outside of this particular event, here is my contact info. The link at the bottom is where I blog my hopefully mostly cogent thoughts. And I'm not much of an agenda guy, so let's jump right on in. So, plan to write your own framework, do you? Don't. Or at least don't start there. At the very least, look and see what already exists that might fit your needs. Why would you want to do that? Well, number one, unless you are an automation framework specialist, it's probably not your core competency. That's not to say you can't do it, or not even to say that you shouldn't do it, but it's not your core competency at your company. Your company is not in the business of creating frameworks. They're in the business of creating some sort of an app, some sort of solution for your clients, your users, or your customers to use. And that is going to rob some of your cycles from actually potentially producing that value. It's called an opportunity cost, the cost of performing one particular task because you're not performing the other task. And it might not be worth it. It might be worth it to purchase something from a vendor or work with some open source software. So writing your own framework is not where you want to start. But there's also something a little more subtle about framework versus stack, and we'll get there in just a minute. But before we go any farther, I want to make it very clear that automation development is software development, and we have to treat it that way. If we don't treat it that way, we're going to have a bad time. We're going to wind up with something that is hard to maintain, may actually wind up being more cost than the value. So we have to be very careful with how we approach this. Additionally, once we understand and treat our automation as software, we can take advantage of some of the established software development paradigms, idioms, and principles. We're going to talk a bit about some of that today. So we talk about the automation framework a lot. I know a lot of us use that term. What is a framework? So by and large, Merriam-Webster says, a framework is a skeletal open work or structural frame. In other words, something you can hang other things off of. And I don't know who said this, but I saw it on the internet one day, and it really spoke to me in that a framework calls you. You call a library. You call some sort of implementation, but if you're working with a framework, you're building in and the framework is calling you. Compare that and contrast that with a stack. Now, we're not talking about the classic computer science definition of a stack where it's last in, first out sort of data structure. What we're talking about is a little more like what Merriam-Webster says. A stack is an orderly pile or heap. So we're going to have an orderly pile of software where each of the pieces of the pile or the layers performs a particular type of activity for us and gains some benefit for us. So we see stacks in our everyday life, right? So we stack of cards, a little sloppy there. Stack of blocks, ooh, a little more sloppy there. Ooh, here we go. A stack in the shape of a pyramid. Very orderly, very neat. So different stacks for different uses at different times. So why do we go with a stack? Well, with the stack, like I said, we can take advantage of certain software development idioms, principles, and approaches, one of which is encapsulation. And encapsulation is the notion of taking software and abstracting away some of the implementation details. A lot of times it will abstract away the specific algorithm you're using. And I'm using the word abstract away a little incorrectly here. It will put a facade in front of the data structures you're using, the specific algorithms you're using, in order to provide a friendlier, more usable interface to people that will be using your software, and also gives you the opportunity to fix bugs, make enhancements, make improvements, change complete implementations, or have additional implementations out from under the software that is using your encapsulation with minimal negative impact and possibly no negative impact to those that are using your implementation. Related and often talked about in the same breath is abstraction. So abstraction in brief is the basic idea of taking the specific and making it more general. And here we have a card analogy where if we've got playing cards, well, every card has some sort of commonality to it. It's got images on it. It's got a front, it's got a back, it's got something on the front, something on the back. Possibly it has a value or denomination. All of these general things can be abstracted away. However, what we're talking about from an implementation standpoint, a heart card is certainly different from a spade card. The spade is black, the heart is red, the spade has that little shovel looking thing on it. The heart has a heart on it. So obviously there are some differences. So the differences, the specific items, are in the implemented part of the abstraction. And using encapsulation and abstraction allows us to build our software in layers. Specifically, for the purposes of this talk, we'll be talking about an automation stack that we build in specific layers with specific purposes at each layer. And we'll go through what the model looks like, and then some specific examples that I've used throughout my career, and then why perhaps I'm not as smart as I like to think I am. But part of the benefit of all of this is the reusability and maintainability we get from using a stack. So why go with a stack and not a framework? Why not even call it a framework? Well, the stack that we're building, again, is not calling into us. We're calling methods, functions, routines, procedures, whatever, in the stack, into the library that has the stack software. Also, there are a lot of frameworks out there already, actual frameworks that are language specific, that are going to cover most of the programming languages we use. Obviously, this is a relatively small subset. Most modern programming languages have some sort of a testing framework or a framework for unit tests or functional tests that can be used with that language. No need to reinvent that wheel. It's very easy to repurpose these particular frameworks to do our test automation with us. So let's get to the conceptual stack. What does this stack that I'm talking about look like in concept? Well, it's got several layers to it. At the bottom is the raw tool layer. And the raw tool layer is that specific tool that you're using. If we're using open source web browsing, perhaps we're using Selenium, or perhaps we're using Appium if we're working with a mobile application. So that's the actual tool that is doing the work for us. Why not write our own tool? Well, if you've got a special piece of hardware or a special piece of software that the existing tools just can't or won't work with in an appropriate manner for you, you may have to build your own raw tool. But if we're working in the web world, most of what we're interacting with, there are some de facto standard tools either in the marketplace or in the open source space. Above that is the encapsulation and abstraction layer. And this is what we talked about on one of the previous slides, taking these basic software development and computer science principles and applying them to software that just happens to be geared toward test effectiveness as opposed to product development. So here what we'll have is a future proofing and help. Future proofing, That's what the encapsulation gives us in a lot of ways, where we can add features, extend features, fix bugs with little to no impact on the above layers. And help. A lot of times they're in the raw tools, they really are raw tools. They give you the ability to do a whole lot of perform a whole lot of powerful activities and tasks, but they may be a little daunting from the programmatic approach, especially if you're not a strong programmer. Not everyone is a strong programmer, and sometimes that can be a little daunting. But even strong programmers are going to start to identify patterns of reuse and build abstractions and encapsulations for themselves to reuse. If we can bake this farther down into the stack, then multiple different organizations and multiple different teams can take advantage of that. Above that, which uses pretty much exclusively the abstraction and encapsulation layer, is the action layer. And the action layer is where we get domain-specific stimuli. I use the term stimuli because if we think about what automation really, really is at its core, it's the creation or the issuing of a stimulus, the waiting for a response, and then checking some amount of that response against either some known goods and some expected responses or some calculated responses. Those things are encapsulated at the action layer. And if you're not following every little bit of what we're doing here, we're going to see some very specific examples coming up over the next several slides. So bear with me just for a few more minutes here. Above the actions, the behavior layer. So if we think of actions in terms of, let's say, a web page, it might be find the login button and click it. That would be an action. Behaviors would be reusable groups of actions. So instead of saying, I want to find the login button and click it, I might say, I want to log in, or I want to empty my shopping cart. So it's a behavior that you would perform as a human, as a tester, as a user, eventual user of the software, to say, this is what I want to perform at this particular point in this test script. Then at the top, obviously, we have the actual test script itself. And along the side there, we have this notion of utilities, which are reusable helpers that don't necessarily belong at the raw tool or the encapsulation layer, because they're not wrapping anything specific to the raw tools. They're more general sort of file system helpers, like reading and writing XML files or reading and writing JSON files, perhaps database access, mail access, anything that you might want to use at different layers and should be accessible at all the different layers, but aren't necessarily at the lower part of the stack itself. So here's a conceptual example of what we're talking about. Let's say we have a whole bunch of test automation scripts. And for 400 of those scripts, we have to log in prior to being able to do the subsequent test steps. So as you can see here, we call login, and login is a behavior method. So it calls the behavior method login. And the first thing it does is it locates the login link and then it clicks it. So that login link locator there, that's at the action layer, and it's locating that login link by its ID, which happens in this case to be food. So you might say, hey, this looks a little overkill for just one call to a locator. I could easily put that in all 400 of my scripts. Absolutely, you could. But something happened. Something changed in the structure of your HTML. Now this ID is bar, either because the developers weren't very diligent about what they were doing. They didn't realize that we were counting on that ID, or in more cases, what happens is the developers are subservient to the framework they're using, and the framework regenerated whatever locator we were using. In this case, it would be the ID. Had we hard-coded that ID in all 400 of those scripts, we would have to go and in each of those scripts change that to be bar. However, here, the actions are holding the HTML structure separate from the behaviors and from the scripts. So we can change in one spot. We don't make any changes at the behaviors, and we don't make any changes at the scripts. And not changing the scripts is a big deal. The reason it's a big deal is, number one, we usually have way more scripts than we have behaviors. Also, you can think of the script as an executable contract between what we think we want the product to do and what the product actually does. And the script can determine whether or not our expectations are being met, or at least the specified expectations are being met. If we have to touch the scripts, that means we have to go back and revalidate the scripts to make sure that they are still checking the same expectations that we want. And we typically don't want to modify those scripts unless the behavior of the application we're testing has changed. So now we start seeing the word behavior appear in conjunction with the scripts, because the behaviors and the scripts have more to do with how the site, the application, whether it's a web or whatever, functions, as opposed to how it is structured and how we want to poke and prod the specifics of it. Now, we'll notice a lot of the examples here have to do with UI, web-based, browser-based applications and automation. This approach works just fine, and we'll see examples again here shortly, for non-UI as well, for web services, for database, for telecom messaging, which is what our first example is going to be. So we'll get to see all of these types of applications here. So great, now we see what we can do when there's a change at the structure of the HTML and what's going on with the specific actions. But something else has changed now. Now we have to check two pieces of data, two beacons, if you will, to say, yes, I now know that I am logged in. Previously, all we did was check, hey, if there's a logout button, then we're logged in. That's a pretty good estimation. But now there's a second thing we need to check. Is the profile link there? So again, had we had all of these individual steps throughout our 400 scripts, we would have to go in and change that in 400 places. And sure, with advanced text editors or grep and awk and sed, we could do this from an automated standpoint. But then you've touched a lot of things. You've touched your scripts. You need to go back and do a lot more re-verification, again, making sure that the expectations are being met than you do if you go with this code implementation approach. Because all we have to do now is add that additional check in the behaviors. The HTML didn't change. The existing HTML didn't change. It was added HTML, but nothing changed in the existing HTML. And we didn't change the scripts. We didn't change our executable contract. This all can lead to less maintenance. Getting a little less example-y and a little more concrete, here's an example of abstraction and encapsulation. There's a software package out there called MAQS, M-A-Q-S, and it stands for Magenic Automation Quick Start. Softvision, or Magenic was recently acquired by Softvision. We still got some of the historical naming there. So this is something that was developed in-house. It's 100% open source. You can go download it now. There's no cost to you. There's no payment to us for this. But this is an actual example, or at least it was as of a couple of months ago, of some of the code there. And you'll notice here we're calling element contains expected text when we want to wait for an element that contains expected text. What we can do here is say, make a call to this element contains expected text, and that second function, that second method, the one that the arrow is pointing to, can be and is used in multiple different places when we want to wait for an element to have the expected text. So we can reduce our maintenance, reduce our duplicated code, which is largely what reduces the maintenance there, by making this level of reuse. So these are examples of actual code that is, or again, were at the base of the MAQS stack and the encapsulation and abstraction layer. So going to a more concrete example of actions, you can see here we have a page model. And this particular page model, it's for the login page. So there are three interesting pieces on the login page: the username input, the password input, and the login button, each of which has this find element. And we abstract this away. We've got the particular CSS selectors for the elements that we're looking for. We could abstract this or encapsulate this even farther by putting it into perhaps an object store. But really what we have is an in-place in code object store here, because all of these selectors exist in exactly one place, exactly the place where they'll be called from. So if name needed to be changed to username, we would have exactly one place to change it. And then from a behavior standpoint, when we want to enter our credentials, well, we want to type in our username and we want to type in our password. So we make the calls from the behavior layer into the lower layer, into the action layer, where we have our selectors defined, and then we can reuse enter credentials in as many different scripts or other behaviors, excuse me, other behaviors that we would like to use them in. And then looking at a script example, here we say, hey, I want to be able to log in and purchase a CD. Well, we don't get to the CD part yet, but here we're going to do a login. So we're going to enter our credentials. We later press the login button. Why don't we press the login button inside of the enter credentials? Because I got bit by this many, many years ago when I worked at an ecom company. I wrote the code for login, and the code for login did the ID, the password, and clicked the login button. And then I said, why don't I just go ahead and click the login link that takes me to the login page? Well, you didn't always have the login link to click, depending on what point during your purchase that you were going to be entering your credentials in. So there's this weird sort of black art about how many things you put or how many actions you put into a behavior versus having less compound behaviors and calling more of them. It is definitely context specific. You're going to have to evaluate that on your own, and you'll probably have to evolve as you go there. So a specific example of something we did at a telecom company I worked at, looking at the conceptual model again, the raw tools we have were some proprietary APIs that pointed to and interacted with some proprietary hardware. This was stuff that was just ours, so we had to develop the APIs ourselves. Above that, in the encapsulation and abstraction layer, we had something called the test head. You could think of this as sort of like a big fat device driver, like a huge device driver that knew how to speak to the proprietary APIs on one side and the more generic portion of the tool on the other side. Above that, we had a layer called the test services, and the test services were specific to each of the type of protocols that we were working with, and they would speak to the test head on behalf of the behaviors, which were sort of a DSL, probably not the DSL we normally think of from a Cucumber or Spec Flow kind of standpoint. It was really more programmatic, but it abstracted away a lot and encapsulated a lot of the specifics of the test services that allow us to say things like go off hook, test for speech, all those types of activities that we would want to do multiple times during a telephony test case. And we wouldn't have to repeat that code throughout the individual test scripts. And above, we had test scripts in C++, because that was the language that the rest of the stack needed to be in. So the test scripts were in C++ as well. And we did have our set of utilities that we could reuse. Looking at this in a more graphical diagram way, this is sort of what the network layout looked like. So we had these shared terminals, we had these individual terminals connected to shared workstations that would speak across the corporate network over to the proprietary hardware, the single board computers that would talk to the proprietary telephony hardware, and then to the system under test. So we got kind of lucky with our breakdown here. Most of us had some sort of programming degree, whether it was engineering or computer science. So we understood encapsulation and abstraction pretty well. We knew about breaking up into layers, but we didn't really think about breaking it up conceptually the way we saw in the model I showed before. But we got lucky because the break across the corporate network forced a hard break in between the test services and the test head. So we had to necessarily have a clean interface there. So following that stint, I went to the e-commerce company and we developed, again, according to the stack, but I didn't have the quantification of the stack in my head at the time. I had it sort of conceptually, but not anything as well defined as this. So our implementation was built this way. We used something called web spec, and it was in the days where Selenium WebDriver wasn't quite where we needed it to be from a stability standpoint. So we went with something called web spec, which was also called wattage, because the guy that was the main contributor for it sat like 10 feet from me. So if I needed help or bug fixes or whatever, he could bang that out pretty quickly. So we had a good safety net on any sort of support there. And above that, I sort of inadvertently combined the actions layer with the abstraction and encapsulations layer. I didn't realize I was doing it at the time, again, because I didn't really have the breakdown of the individual layers at that point. So I blended them together. And above that, we had our own separate DSL there. And then the scripts were written in Ruby and our set of utilities were done. Then WebDriver was ready to go. WebSpec was not going to be supporting some of the interfaces we needed, like Chrome. So we were going to port over to Selenium, and it was kind of like, I blended the actions along with the lower layer. What do we do about this? Here's where the stack started becoming a little more concrete for me, the conceptual stack, because now we had Selenium. And I built a Selenium wrapper that looked exactly like WebSpec. So we wedged in a shim, if you will, a thick shim that would speak Selenium on one side and effectively WebSpec to the other side to the existing actions, where we only had to make some minor changes to the actions, but no changes to the behaviors and no changes to the executable, to the scripts, right? Our executable contract, except for in each script, we did have to go and change the way we created the browser instance. Apart from that, all the business logic, that contract part, all of that stayed the same. So we were really fortunate there. This really could have been a much more expensive and risky endeavor than it actually wound up being. So I moved on to a SaaS company. Again, we see our friend, the Conceptual Stack. Again, built on Selenium wrapper. I had learned my lesson. So here, this action finder layer became a little more mature. We went more with page objects and not necessarily the traditional cold page object where each object is a page and each page has an object. It was more of a componentized page object where, okay, each page had an object, but it wasn't necessarily one object per page. It was multiple depending on how complex the page was. If we had lists on the page, it was probably a list component. If we had different panels, especially if there was repeated HTML through there, just for different instances, we would have those as separate components as well. And then the object would be assembled, if you will, based on what the logical visual components would be. And here, our quote DSL layer morphed a little bit. There was interest in doing BDD. Narrator says they didn't actually do BDD, but there was interest in having that capability in the tool. So we built the ability to do spec flow, which if you're not familiar with SpecFlow, think of it as Cucumber for the .NET stack. But for those teams that either didn't want to use SpecFlow, couldn't use it, decided they weren't going to go the BDD route, we had a more programmatic DSL as well. And this was all built in C# because that was the language of the people that were going to be developing the automation. And then to look quickly at the Softvision Max, it looks very, very much the same as what we saw at the SaaS company previously. Here we do support Selenium, Web Service, Appium. We have wrappers for each of those. And we're going to talk a little bit about the multiple raw tools when we get to the adjacent stack slide in a second. We've got the models, because they're not just page models now. There are different models based on which type of raw tool we're using. With Selenium, they're page objects. With web services, they're more like message objects. And we still have the SpecFlow and the DSL, raw DSL approach. And we support both C# and Java. Obviously, those are two different implementations, but you get a little bit of language choice there. So adjacent stacks, a lot of times we'll find frameworks, especially in the open source world, the vendor supplied tools really do try to be all things to everyone frequently, not always, but frequently. The adjacent stacks are the idea of the lower parts of your stack are really substacks because they're actually talking to different types of raw tool. But at some level, usually at the behavior level, you want to be able to blend these all together. And if not at the behavior level, you want to certainly be able to do it at the script level. I would like to have a test script where I can call some web APIs to do some data setup and then do some UI testing either with the mobile or with the browser. Or perhaps I want to be able to perform an activity via the UI. And then I want to be able to verify that the backend, the persistent store, is actually set up with the right data the way I'm expecting it to be. And I want to be able to make API calls to do that. Or perhaps I want to be able to start a purchase on my phone and be able to finish it in the browser or vice versa. All of these would be what I call cross-technology automation, and adjacent stacks are absolutely a way to go to be able to handle this. So into each life, some rain must fall. This whole stack thing sounds awesome, but there are some caveats we have to really look out for, and logging and error reports are really the number one. Layers can make difficult debugging. They can. In fact, I was debugging something with a client a month or so ago, and I went, wow, I think we may have too many layers here, because it really took me a while to get everything in my head about what was happening at each of the subsequent calls. And in that particular case, it wasn't that there were too many layers. It was really that there were too many encapsulations in some of the layers that probably could have been simplified. But to quote Alton Brown, that's another show. But layers can make debugging a challenge just from the logistical nature. But it is very easy to have a higher layer inadvertently hide lower layers details. I call it eating the data. They'll eat the log. They won't take the log that the lower layer gave to them and propagate it up. And not maliciously, of course. It's just something that gets missed from time to time. It's important that each layer logs as it goes, and that it logs in a context-sensitive manner. Because if we go back and look at the stack, the lower you go in the stack, the more interesting it is to the automation team, those people that are creating those stack layers. The higher you go in the stack, the more interesting it is to the actual people performing the test work. So if possible, and usually we can if we're creating our own stack, to log in the vernacular, the vocabulary, the slang, the jargon of whatever set of people is going to be interested in that particular layer. So what we do is we take the lower layer, we wrap its message, its error, its report, with the higher layers interpretation and then send it up to the next higher layer so that we get this stacked effect where the error messages and the logs basically map to the layers of our stack. And this way we can make our logs domain appropriate. So for an example here, again, going back to the ecom site, I like to use ecom sites because pretty much everybody out there has bought something on the internet before. So we all kind of know the concept of purchase and search and adding the cart. But here I just want to buy a CD, right? My kid broke my Bark at the Moon CDs. I want to buy a new one. And I had an error in my test script. So what happened here? Well, at the test script layer, what do we know? We know we failed to add that CD to the cart. That's probably not enough for me to do my job. What really happened here? Oh, okay. I couldn't find the add to cart button when I tried to click it. Now that's suspicious. What's the next layer of the stack say? Couldn't find the ID. This is the part where my particular expertise starts to winnow out. So I'm either going to have to get somebody involved with me, or boy, would really be nice if I knew what that screen looked like when I tried to click, and taking a screenshot helps us out with that, because a lot of times with the screenshot and the first couple of levels of your log there, you can tell, okay, this is a problem with the app because the button's not there, or okay, this is a problem with the automation, or we don't know yet because of just what the particular error happens to be. Now, we've talked a lot about test scripts. So the traditional automation where we have test case plus tool equals test script. We can use this automation stack if we stack our software appropriately outside of traditional test scripts into something I call automation assist. I've got a whole different talk on that. Again, that's another show. But we can reuse different layers of the stack in different types of tools. So here, back when I was at the ecom company, we reused the lower 3 layers of our stack and built something called an order pumper. We needed to pump in a bunch of orders, and we didn't have APIs in the back end at the time, because this was not the right way to do this. If we had programmatic, say, SOAP or REST APIs, we didn't have those. So what we needed to do was make the tester's time more valuable, make the tester more efficient or more effective. So we built an order pumper. We'd make a list of, here are the things we want to run through. This order pumper would go through, reusing the code that we wrote previously for the traditional automation, pump the orders in, make a list of all the associated order numbers. Then when the testers came in the morning, they could go through the order numbers and see that the data was in the back end appropriately in the commerce system. What's the most valuable part of this operation? What's the tester's time? And again, we all have used websites before. And when we use a website, what do? We wait a lot. We click and we wait. We type and we wait. We didn't need the testers waiting for these hundreds of orders to have to be put in. So we'd run it at night, let the machines do what they do, which is crank through things and not have to go to sleep. And then the data was there in the morning for them. So it wasn't automation in the traditional sense, right? There was no pass fail. There was, here is a list of information that we cranked out for you overnight. Now you go do your human tester thing. Similarly, we built something called a random link clicker, using, again, the lower layers of our stack. The idea of the random link clicker is to go through and click various pieces of your application, looking for things that are weird, unexpected stuff. This is sort of a weird approach to basically UI fuzzing. What is weird? Well, a 404 would be weird. A 500 would be weird. Going through and just clicking for unexpected pieces where you are really testing with no oracle, a true fuzzing, or where you're testing with a very, very small oracle of, I know the word error shouldn't appear in any of my pages. Now we get to the Paul is smart part. I thought I was a genius for coming up with this stack, but it turns out I wasn't. People either beat me to this, and to say that I came up with this on my own is also disingenuous. I've worked with a lot of great people throughout my years, and I've been very fortunate that way. But around the same time that we were creating this conceptually, and actually before I even wrote it down in that level of stack, Dorothy Graham and Matt Fuster wrote a book called Experiences of Test Automation, and I highly recommend you read that book. A lot of the specific examples are dated from a technology standpoint, but the concepts and the idea of this is still being run, this died before we really rolled it out, very, very enlightening about what was working and not working for different people in different contexts. But if you look at this stack looks very familiar compared to the things that I talked about earlier. And if you're looking for something a little more current, John Ferguson Smart, big name in the BDD area with Cucumber and such, he lays out different layers of different names of different layers in his automation as well, and how he teaches this. So this is not a unique concept from a novelty standpoint, right? Other people are doing this, calling it by other names. I just happen to be the one talking to you about it today. So the reason I bring this up is because, well, number one, I want to give credit where credit's due, but also I want you to see that this is not just a one-off squirrely thing this ball-headed dude came up with. This is something that other people are doing in other forms as well. But beware, again, into each life, some rain must fall. There's another kind of stack that we really, really want to avoid, and it's this one. It's the house of cards. If we are not careful and judicious about how we create, build, and maintain our stack, the slightest little breeze that comes along is going to blow it down, and we're going to slowly start eroding any value that we may have gotten from there. So what do we do about that? Well, we think about this from a standpoint of stewardship. I used to work with a guy named John Prince, and he would say, no, we don't own quality. We're the stewards of quality. We are responsible for seeing quality through and helping other people do the things that help us have a quality product. So from a stewardship standpoint at the automation stack and architecture level, we talk about what goes in which layer. It matters and it doesn't. I mean, conceptually, it matters. But from does this particular method call belong in this object or that object? It matters that everyone or the appropriate decision makers agree that it's appropriate in that layer for your context, which might be different from my context or person over here's context and person over there's context. I always love pointing at the camera. It's going to be context specific. And you need to make those decisions in your particular context because you've got a different automation ecosystem than anybody else does. What matters is that someone or some set of people is overseeing what's going on, and we're making consistent decisions, and we are prepared to evolve when our previous sort of decision-making process isn't delivering exactly what we wanted it to. And I highly recommend programmatic checking of different aspects of the delivery and the development. What I mean by programmatic checking is static analysis and where appropriate, dynamic analysis as well, because remember, this is software development. So those tools absolutely play a role here. And what it can do is it can remove some of the, I think this is better, I think that's better on an individual standpoint, because people agree on the rules are implemented. They're implemented as part of your standard build process. If you have a failure because of a rule violation, you go back and you fix your code. That's been pre-decided. It takes a lot of the drama out of what might be going on. So general guidance, I get questions about how do I generally do this? So there's a break here in the stack. And the two pieces at the bottom are typically more general. And by more general, they are applicable across multiple different applications, multiple different teams, multiple different organizations, where the ones more above are more domain specific. So when I worked at the ecom company, we had 3 different websites, and we were able to reuse our abstraction and raw tools layer across each of the websites. But each of the websites had different HTML. So the actions layer and behavior layer all had to be different because it was slightly or a lot different to interact with each of the sites. Again, so it's less granular as you go up. Things like login versus find the login button. And it's okay to allow judicious access to the lower layers from higher layers. What do I mean by that? Should a behavior layer method call into the abstraction directly? Maybe, maybe not. There's a risk. The risk there is if you change the abstraction layer, then you're not protected by the actions layer anymore. You're going to have to change whatever you called at the behavior layer. If there's a negative effect there for you. So judicious access there is probably fine. You'll remember in the layers picture where we had the nice cake with all those M&Ms falling out. That's what a lot of our stacks look like, right? We've got these neat layers where we allow the higher layers to occasionally blur the lines and what they should be calling next. It's not inherently bad to do that. It's inherently bad to do that non-deliberately. You have to deliberately do that, making a very conscious decision about how you're going to do it, why you're going to do it, what your remediation is going to be if you were to have to make some changes that would potentially break higher layers. So a little TLDR for you. Stacks are portable. You can use them in frameworks. You can use them in non-traditional automation. When you're working with a stack, use software development idioms, use your encapsulation, use your abstraction, use anything else that's appropriate for the language dynamic or the language specific that you're using. Remember, appropriate logging and error messages are absolutely critical, and stewardship is required. Otherwise, you run the risk of having that house of cards. And now I've got time for questions.
All right, we have one question here. How's the best way to pass data in your example between steps and arrange and assert, for example, using some context?
What's the best way to pass data? So if you're passing data between method calls, you just pass it through method calls. But if we're talking about passing data between individual test scripts, that is usually what's called an anti-pattern. Test scripts should be relatively atomic. The smaller, the better, but sometimes we need to automate longer strings of steps to get from point A to point X. But you would not want to set up data in test script 1 and then use it in test script 2. So I don't have a best way for that because there's generally not a best way for that. If that's not the question you are asking, please rephrase it in the chat and then, or the Q&A, and then she can re-ask it for me.
Let's see, no other questions yet, but lots of rounds of applause and thumbs up.
Well, thank you very much. Thank you for your time, everyone. I really appreciate it. I'm happy to hang on another minute or two. I don't remember if we end at 10 to the hour or 5 to the hour, but I've got the time free. So if you want to sit there and noodle on it for a minute, no problem. If you're not an interaction in large public settings person, no problem. Here's the information on where you can reach me. Plus, if you're happen to be a Softvision employee, you can reach me on the internal communication mechanisms as well.
All right, and Norma says, thanks a lot, great session.
And thank you, Norma, much appreciated. And thank you for your time.
All right, thank you, Paul.
All right, everyone have a good rest of your day, and I'll see you on the interweb.
We are no longer live. That's all. Thank you, Paul.
Thank you. Appreciate
the help. Thanks, that was great. I love awesome. the speaker that you've got. It's very radio quality too.
Oh, so
or the mic.
A conference that I was speaking at, they sent us microphones. So it's not the Blue Yeti, it's the Blue Snowball. And then I've got it hooked up to this thing called Voice Meter, where you can adjust like the different tones and things, because normally it sounds really kind of dead. So I've been playing with that and I've been anxious to use it. So this has been this one and the internal session have been my chance. So I'm glad it sounds good.
Yep. Well, thank you again. Let's see, we've got 2 more sessions for the day.
Awesome. Hey, thank you all very much, and see you around.